Hello everybody. I'm going to talk about distributing the GraphQL to countries and places on the world where there are no data centers, basically, and where you need to solve all the latency stuff and all the data bandwidth stuff. And it's not so easy. But first things first. My name is Riedl. I'm mostly backend developer and delivered a lot of APIs in my past. And in last year maybe, I'm focusing more on GraphQL. And still thinks it's pretty cool technology. And currently I work at iflix. And because most of you never heard about it, its basic mission is to redefine television for 1 billion people. And how we do that is that we are creating global video on demand platform for emerging markets. And you can imagine that as Netflix for these markets. So Netflix for Southeast Asia, for Middle East, Africa. And going to these countries requires completely different challenges. And one are from content perspective. These people don't want to watch only Hollywood, but also Bollywood, local content. And so we need to have subtitles for everything. But it comes also with a lot of technical challenges, because these people don't have computers often. They don't have so many smart TVs, but they have mobile phone. And often they don't have even internet at home, but they still want to watch the movie. So we needed to come with solutions like download and watch offline, so they can download the movie at work and bring it home and watch it at home. And to make the service accessible for as many people as possible, we often close partnerships with telco providers, so they can bundle iflix to their data package, and it's more available for the end people. And these partnerships will be pretty important in next phase of this presentation. And just for you to imagine what regions we are talking about, on the map, you can see that Africa is pretty rolling up in last days. But where is the technical catch to deliver the data to these countries? And we can start with the map itself, because it sounds good, it's not so much, but when you combine that with AWS data centers, it's not so easy. So Southeast Asia is pretty fine because there is a data center in Singapore, but for Middle East, maybe in India, but in Africa, there is no. So all of these needs to be handled somehow. And another thing what we need to do and what our API needs to work with is that we have multiple different applications with multiple different user experience. And with every user experience, it requires different data. So we have web application, as everyone basically. We have mobiles, fine. But then we have plenty of smart TVs. And this is completely different UX. And also, every application looks a little bit different, because Samsung application needs to look as a Samsung application, and Roku application needs to look as a Roku application. So with these, we have different requirements on our data every time. And for some of these devices, we need to take care about one more thing, and that's a release cycle. Because for some set-top boxes or here mentioned Alibaba TV, the release cycle is half a year. So when we want to deploy a new change, we need to wait half a year. And another thing which is against this, our business is changing very rapidly, and we need to evolve the API pretty fast. Because right now, we have around 20 engineering teams working on new features. And these features are delivered every day, but they are delivered in 4 different time zones. So you cannot somehow tell the developers, wait until I will approve that, or no, they cannot wait. And also, what's going on is that because iflix was built very fast, we need, and it was a lot of shortcuts have been taken during that time. We are now in process of large refactoring of a lot of our services. So we need to continue the evolution smoothly and don't break the release cycle, as I mentioned before. What is needed to be taken into account is also the load. Right now, iflix has more than 4 million users, which generates 130,000 requests per minute to the APIs. But our vision is to reach billion users. What will be the load that time? It will be insane. I know guys from Facebook, GitHub knows these numbers, but not for everybody. So to describe a little bit our data, what we are talking about, I will talk mostly about API because that's how we solve that. So, but we still have video data, the movie itself. It's pretty easy to distribute-ish. Okay, we just need to take care about DRM stuff, and the movie itself is deployed to CDN, and when user have proper tokens, he can download and watch the movie. Most of our catalog of the movies and TV shows is pretty static, and it doesn't change often. So we can cache this data for a long time, and we don't need to check it on every request if they are fresh or not. Then there is a different kind of data, and that's like personalized collections. Because someone who likes action movies will get different homepage than someone who likes romance movies. And if we want to serve different data to each user, we need to have some logic to discover that, and which needs to be authorized because the specific user loves the action movies. Also, we have dynamic data like watch history, which is when are you watching movie, it gets recorded, and when you go out of the application, you want to see what you watched, and so you can continue. And this updates very quickly, and it's strictly private because you don't want to know that you don't want anyone to know that we are watching Hello Kitty, right? So that's something which needs to be protected, and so it cannot be just staying anywhere on public API. And last things are DRM tokens and DRM data, which are based on principle of one-time use key. So it cannot be cached at all, and it needs to be resolved every time. So how we approach this business? How we approach this problem. At the beginning, as most of the services, it grow fast, so we had a lot of microservices and clients were accessing directly to them. And it has a few benefits, like if one service fails, most of the product still works. But so we come with idea that if the catalog doesn't change often, we can generate the static data and upload them into CDN. So, because CDN will not fail, probably. And so we come with that idea that all the assets, all the categories, everything can be just generated as static JSON files and uploaded to CDN. And using this, we also solved part of the problem which is distance to the user. Because the CDN itself is much closer to user, it's within his region, so there is no main problem of accessing this data. But so let's do a quick review of this solution. The last mile problem is pretty good. We are close to them. Scalability is also pretty good because we don't need to care about 70% of scalability because it's handled by CDN. And, but it's not flexible at all. Because when we have the REST-ish approach, which was mentioned before, that we generate views for every application, we need to get different views for different ones. And if we want to just add new data on and show new data to the user, we need to go to backend and do some magic there and upload new data to CDN. So it takes a lot of hassle. And also, when we want to do some backend change, we need to update all the front ends. So it's not even maintainable easily, because every change requires a lot of work. So we sit down and think about how we can solve these problems with the approach. And because we are on GraphQL conference, you maybe guessed that we created GraphQL there. And we put GraphQL gateway in the middle as integration layer, which basically decouples the front end from back end. So we can generate only one form of data into static files and let the client decide what part of this data he wants. Also, within the gateway, we built in the authentication. So if we want to serve personalized data, we can serve them to specific user from static files, and we don't need to implement any more logic on client side. And also, to solve the problems with evolving the schema, the GraphQL comes with great toolings for that. So when we want to add new version of the service, we can just edit a side of the old ones, keep them run both, and modify a little bit the schema to retrieve some information from version 1 and some information from version 2. And when the client applications gets updated and only consumes the new version, we can just throw out the old one. And with these changes and with this integration and evolving schema on the GraphQL gateway, we are able to constantly get better. But when we come with this, the last mile problem becomes still bad because it's a service. It runs in data center. And because it's service, the scalability is not good by design. Because you need to handle the load in some server, and it's not so nice and static like in static files. But the flexibility becomes excellent, and maintainability becomes also very good. So we were still thinking, okay, can we combine these approaches? And we come with idea to create a GraphQL gateway box, which is basically infrastructure-independent Docker container. And using Kubernetes, we can send it all around the world. And because it is stateless, we get this box and bring it as close to user as possible and start caching within that box. And as I mentioned the telco partners, we can even get to them and ask them for a few servers and run the GraphQL gateway box within their data center. So the request gets resolved as close to user as possible. And to a little bit get deeper about the caching, how we were approaching that, because that's like the most important part of the gateway, is that when you deploy there, and we have imaginary one request, which have 10 requests on the backend. Every request overseas have from data center to data center up to 400 milliseconds latency. And I'm not speaking about bandwidth, which is not as good to Africa as well. So the first idea was, okay, this is not good. So we have the data on static CDN, so it's much better. 70% basically are static requests. So if the basic request contains only data which are in static files in CDN, it gets resolved within the region and doesn't need to touch the data center. But still, there are requests which requires to touch the data center. And so we uploaded also the personalized collection to the CDN and put the logic with authentication part into GraphQL gateway. So when user comes, we already know that he likes action dramas, and we can serve him his personal homepage, which is the same for group of people. But different basically for anybody else. So in this case, we are resolving even more within the specific region. And we were thinking even further, what can we do with private data? Because private data cannot be cached on CDNs in general. But we thought, okay, but we have authentication within the gateway, so we can cache the data personalized and let the user itself access his private cache within the gateway. So in this moment, we were requesting only the DRM to the backend, and if it's cached, almost everything except the playback stuff gets resolved within the region. So this offloads a huge load from data center itself and helps us to serve faster to the user. But can we go even further? And we find out that yes, we can, because we added the cache itself also for the static data within the GraphQL gateway. So it is not resolved within a matter of 10, 20 milliseconds, but it's resolved within the millisecond. So if comes one request with 10 subsequent calls, we resolve as many as possible within one service. And to go to review a little this solution, we can say, okay, last mile is excellent. We are really close. But scalability is still only good. We offloaded the backend, and we deployed it to the data center where user is, so the chunk of load is pretty small, but it's still a service. Flexibility is still excellent, and maintainability is still excellent as well because of the GraphQL. But we were thinking, okay, can we fix the issue with service again? And we put CDN in front of the gateway as well. So when user is requesting the data, if someone else, like for example, category or detail page, which is the same for everyone and contains only public data, we can cache that on frontline CDN. So basically, all the same requests which were static in the first version are static right now as well. But how to handle all of these is that pretty easy. We have already standard for that, and that's basic HTTP headers. The microservices on the backend are, for every response they are giving, are adding caching headers. And this tells all the services above them how to cache and how to manipulate this data. So they tell us if the data are private. They tell us if the data can be cached for 10 minutes or 10 hours. And the gateway does that it aggregates all these information, find the smallest intersection, and with that responds through the caching CDN. So in that case, we can be 100% sure that private data will be never cached on the front line. But when someone requests public ones, it's cached there. And also, with this, we don't need to know basically what are the data, what is their structure in the gateway itself. It's just smarter proxy, which knows how to handle the data, but doesn't know what it contains, how long it should be cached. So with this solution, we are pretty fine with what we built because the scalability is also excellent, and we didn't lose any major problem. So to do a quick summary of what we built is that we created integration layer using GraphQL Gateway, which decouples the front end from back end. We are using continuously evolving schema to keep the business running even for long cycle applications. We generated everything statically, what is possible. So all the files are static, at least where it can go. We are caching a lot within Gateway, and all the caching is controlled using HTTP headers. And the most important is that we pick the gateway and add it to the region itself, so it can get resolved pretty fast. So this is our solution, how we did it, and if you have any question, get in touch with me on standard channels.
All right, thank you. We have time for a couple of questions.
Great.
If you'd like to ask, I will bring the microphone to you.
Great, thanks you. So in terms of authentication, how do you authenticate a user out at the gateway? I mean, you need to...
Yeah, the authentication is provided using OAuth2 server. So we just get the token of the user and we can identify him properly in there. So we are using for password flow for most of our application. And if we want to publish in future, we can just add standard OAuth flow into that.
Okay, and one more question in terms of authentication. When you have authenticated the user and he goes to the gateway, but there is no data there, and you need to pass along to the backend server, do you then re-authenticate him at the backend server?
No, we use JWT tokens to identify the user and his information between services. So it's the service itself knows what user is coming and trusts that because the JWT is signed.
Another question? Nice and close.
Hello. What is the format of the data in the CDN, especially on that one which is before the GraphQL gateway? Because it cannot handle any logic, as I understand.
Yeah, that's just a standard caching which is provided via the CDN. So basically, most of the data are a query, so we use GET request for that, and the CDN is caching our GET request based on the URL. So if the request is still the same, it gets the same response if it's cached. Yeah.
We can have one more question. Yes.
Over there, yeah.
Great talk. How does the GraphQL gateway communicate with the various microservices?
Mostly by RESTful-ish APIs.
All right, thank you very much, Jakub.